Everyone, myself Rishta Pemireddy. Welcome to this session on Navy Bayes, one of the simplest yet powerful classification algorithm in machine learning. Today we are not just going to learn what it is, but we will break down it into simple parts so that even you have never touched machine learning before, you still understand it clearly by the end of this session. What exactly is Navy Bayes? As we know, Navy Bayes is a supervised learning algorithm. That means the model learns from labeled training data. For example, we give the algorithm many email labeled as spam or not spam. It uses those labels to learn patterns and then make predictions on new unseen emails. Next comes probabilistic classification. Navy Bayes is a probabilistic model. That means it does not say yes or no with full confidence. Instead, it gives a probability. Example, given a word in an email, it might be 85% it's a spam and 15% it's not a spam. And whichever is higher, it picks that category. Next, Navy assumptions. Here where it gets its name. Navy. It assumes that all features are independent. That means it treats every input, like weather, humidity, temperature, as if they don't affect each other, even if they do. For example, it assumes the word free and the word money in an email are unrelated, when in reality they often come together in a spam. This assumption is what makes the algorithm simple and fast, but surprisingly, it still performs well in practice. And finally, it's all based on Bayes theorem, a formula that updates probability based on new evidences. This is mathematical backbone of Navy Bayes, and we look at that closely in the next slide. So we'll know further why it is called Navy. Navy means, as I said, it's assumptions. The reason it's called Navy is because it assumes all features or input variables are completely independent of each other. But in real life, that's not true. Features are often dependent on each other. For example, let's say we are, for example, let's say we predict whether to play a tennis or not. The input might be weather, humidity, or outlook humidity. Outlook may be sunny or rainy, and humidity may be high or low. Now, think about it. If it's rainy, humidity is like to be high, right? But Navy Bayes treats them as if they are unrelated. Even with the unrealistic assumptions, the model performs really well on tasks like spam filtering, document classification, sentimental analysis, and many more. Now let's dive into Bayes theorem, which powers the Navy Bayes algorithm. Bayes theorem helps us to update our beliefs based on new evidences. The formula is P of A by B is equals to P of B by A into P of A by P of B. Let's break down the formula. Here, P of A by B is posterior probability, means the probability of A happening given B is true. For example, probability that an email is spam given it consists the word offer. P of B by A means likelihood probability, the probability of seeing B when A is true. For example, how often does the word offer appears in an email spam? Here, P of A is A before seeing the evidence. For example, what's the percentage of all emails are spam? And P of B is evidence, the overall probability of seeing the word offer in an email, spam or not. Let's break down it with an example. Now, imagine we've been, let's imagine we have been tracking the weather and we need to decide whether we play tennis or not for next 14 days. Based on the history of data, we want to predict if we should play tennis today or not. As the conditions are given below, outlook sunny, temperature cool, humidity high, and wind strong. The question is, should we go out and play? Let's find out with the Navy Blaze classification. First, we need to calculate the prior probability. Let's say we have 14 days of history of data. On 9 days, we played tennis. P of yes is equals to 9 by 4, which is equals to 0.64. And on 5 days, we didn't play. That is P of play tennis is equals to no 5 by 14, which is equals to 0.36. Next, we need to calculate the likelihood probabilities. We'll look at how common features is given that we played or not or didn't play. And the table goes like the below. Next, now with the help of Bayes theorem, that is P of A by B equals to P of B by A into P of B, P of A by P of B, we will calculate P of yes and P of no, which is if we want, we need to first calculate P of yes, which is equals to 0.0053, and we need to calculate P of no, which is equals to 0.025205, and we need to compare the both values. Which is higher, the probability of getting the answer is that, and the prediction is no. Now, now we have seen how Navy Bayes works. Let's answer an important question. Why should we learn Navy Bayes in first place? There are three big reasons. First one, applications in real life. Navy Bayes is used in many areas of machine learning and AI that impacts us every day. Example, spam filtering. Gmail uses it to detect spam emails based on the keywords. Social media platforms uses it to detect hate speech or sentiments in the post. So whether you're dealing with text, numbers, or symptoms, Navy Bayes finds a place. Second one is high accuracy and speed. Navy Bayes is extremely fast to train and test, even with the thousands of data points. Compared to complex models like neural networks, it performs very well, especially in text classification. Next comes the efficiency. Next comes efficient on small datasets. Navy Bayes gives good results even when there isn't much data to begin with. Next comes efficient. Next comes efficient on small datasets. Navy Bayes gives good results even when there isn't much data to begin with. This is helpful when you are working on small projects or in a situations where gathering data is hard, like in startups, research projects, or early prototypes. So, in short, Navy Base is like your go-to friend when you want to quick, smart, and simple predictions. Next, next comes applications of Navy Base, where we use Navy Base. It is used in spam detections. Words like free, money, win, if they appear often in a spam email, Navy Bears detect them and block them. Next comes medical diagnosis. It is used to detect whether a person is diabetic or not, or doctor uses it to predict diseases like diabetes or flus based on the patient system based on the patient symptoms like fever, cough, cold, etc. If 80% flu patients show cough and fever, The model uses those features to make a likely diagnosis. Next comes sentimental analysis. They, this is where we analyze our opinions, like whether a product review or a tweet is positive, negative, or neutral. For example, you write the movie was amazing. Navy Bears check the words pattern and assign it to a positive class. Next come recommendation system. Based on your past behavior, Navy Bears can suggest things that you might like. If you bought a mobile phone, it might recommend a screen guard or case. It calculates which product are most likely to interest you. And it also helps in document classification and language detections. Next come types of Navy Bears. Let's understand the three types of Navy Bayes algorithm and when to use each. First one, Gaussian Navy Bayes. This one assumes the data follow a normal distribution. It, it used when features are really valued like height, weight, temperature. Suppose you classify flowers in a iris dataset based on the petal's length, spatial width, etc. Gaussian Navy Bayes is ideal. Next comes multinomial navy Bayes. It is used for discrete counts like how often a word appears. In spam filtering, we count how many times a word appears, like offer or win, how many times it will appear, we check. That's where multinomial navy Bayes comes. It is used in it is used in text classification, document categorization. This is go-to algorithm. Next comes the Bernoulli-Navy bias. This is for binary features like yes or no, one or zero, present or absent, like that. For example, in spam filtering, we just care whether the word win is present or not how many times. We use Bernoulli. In that cases, we use Bernoulli. It just see if a word is present or not. It doesn't count how many times it appears like multinomial navy Bayes. It is used in application features like where the present matters more than the frequency. So depending upon your data set, you choose the type of navy Bayes. In coming to the pros and cons of navy Bayes, every algorithm has strength and weakness. So as navy Bayes. Pros of Navy Bayes. These are fast and simple. It trains and predicts quickly, even with a huge amount of data. Performs well even if you only have limited examples. And it is text data friendly, means excellent with words. It is mainly used for spam filtering, tweets, reviews, etc. And it handles irrelevant features. Even if you give it extra useless features, it's smart enough to ignore them. Next comes the cons of Navy Bayes. It assumes features are unrelated even though they are related to each other. If something never appeared in training data, it gives a probability of zero. But we can fix this using Laplace smoothing by adding a tiny number to it, and it not as powerful as complex models like decision tree, random forest, when patterns are very nonlinear. Still, for many tasks, Navy Bayes is great starting point. Coming to the conclusion. So what we have learned, Navy Bayes is a fast, simple, and surprisingly effective algorithm. Even though it assumes features are independent, it still works well in many real life tasks. Whether it's a spam detection, sentiment analysis, or language detection, Navy Bayes helps machines make smart guesses based on the past data. It especially used when you have small data set, you want quick results, or you need easy to understand predictions. And thank you for all your attention. I hope today's session helped you understand Navy Bayes better and how it works and where it's used and why it's valuable. And thank you.